ecological skepticism and predictions. It's fundamental in science, and we'd like to raise a few points that you ought to know. The first one is that all forms of human searching for knowledge involve creativity. Without creativity, we can never understand the world better than people before us. But equally, without skepticism, we might fool ourselves about whether our creative ideas warrant our confidence or not, and that's what sets science aside, as our longtime mentor here, Carl, tells us.
There's many different things that we try to predict in ecology, and some of these are more reasonable than others. Nassim Nicholas Taleb came up with 4 different quadrants based on their predictability. They have different probability distributions, some of them being normally distributed, meaning there's like a mean tendency and not too much variance around the mean. And then other more skewed distributions where it's harder to predict what's going to happen at the tails. And then possible outcomes are binary, so it's like a flip of a coin. You only have 2 possible outcomes, or you have really complex outcomes, almost anything is possible. So then these fall into different realms. The first one being the known knowns. So those are pretty easy. We know that it's going to be heads or tails, or we know that a baby elk is going to grow up to be a big elk. Then there's unknown knowns. So perhaps we know that there will be most likely a large wildfire, but we don't know exactly what year that will happen in. And then with known unknowns, this could be with maybe population growth of some wildlife species. We don't exactly know all the parameters for birth and death rate, but we know that we could figure those out. If we got there normally distributed, if we go out and gather more data, we would be able to predict that. And then the most sticky quadrant is the unknown unknowns, because we're not quite sure what we don't know and when they'll happen. And those are also known as the black swan events. And those are what we really have to look out for. That's like market crashes, or maybe a huge hurricane or an earthquake, and that can really disrupt our predictions. And since we can't predict when those will happen, watch out for them, but you don't know what to watch out for. So good luck.
Just a little bit of history of past terms used in ecology. I pulled some of the most common words used in titles from the Ecological Society of America Journal Ecology of the 1920s, 70s, and 2010. And you will notice that in 1920s, that soil, weather conditions, a very regional, local distribution of terms was used. It was not exactly precise for predictions. By the time we get to the 1970s, a lot of the terms are very familiar to us, and there is more experimental work that is used. What's also interesting is during the 70s, there was a lot of laws, a lot of acts in U.S. history that was included, including the Endangered Species Act. And by the time we get to 2010, we find just the word predicting common in many of the titles. And this is just from 5 to 7 major publications of the year 2010.
So as ecologists, we need to be very careful and cognizant of using skepticism and criticism in their appropriate places at their appropriate scales. So for skepticism, we want to think of the ideas and concepts and theories that sort of drive the background of ecology, and save criticism for the presentation of the ideas, the analysis, and down all the way to the writing style. So we need to think about, in order for us to be critical, which is sort of what is easier for us to do, we need to be skeptical of the ideas, make sure that they're backed up. In this sense, we do want the chicken to come before the egg and be skeptical before we're critical.
Here are the 6 keys to a good prediction. The first is being precise, and that the more risky the prediction a theory makes, the better it is to test. The second is proper scale, where scales that are amenable to modeling should be used. Third is probabilistic, that includes an estimate of uncertainty. Fourth is place-specific, where place or condition-specific predictions for both applied and research. Fifth is prolific data, where having more input data is better for modeling. And fifth is public, where if you are wrong, you should own up to your mistakes.
Okay, so oftentimes when we make predictions, we try to make them using statistical models. And then we evaluate those statistical models using this magic thing called the p-value. I would argue that you should be weary of p-values or wary of p-values, because Actually, most scientists, even after years and years and years, have no idea what it actually even is. And there's a bunch of other reasons, arguably, why the p-value is maybe not so useful. But I would say there's other options that you can use for making statistical predictions and for evaluating models. So one of them is called information theoretic, which is AIC, which is also arguably just another number that a lot of programs that you use will spit out, and you'll say, let me minimize that so I can have the right answer. But I would argue you should take the time to really learn how to work in the Bayesian paradigm, because you can actually make probabilistic statements about the uncertainty that you may have about any of the predictions that you may want to make.
So when we're deciding if we should be skeptical of something, a good way is to look back on how past predictions went. I'm going to use the example of species extinction. In 1992, it was predicted using the species area curve seen here that we'll have a yearly decline of about 0.25% in species richness. And a lot of us has gone into the idea that if you decrease area, say through deforestation, you're going to see a reduction of species. Let's see how that worked out. So first off, we do see very rapid extinction on islands. However, this isn't because of deforestation, it's usually because of invasion. Mammals are more vulnerable to habitat loss. Between this and the rapid extinction on islands, it makes most sense to look at the species area curve in the context of continental mammals. So our earlier prediction would predict a loss of about 11 continental mammals every year. Since the 1500s, we've lost 64 mammals, which is a bit short of 11 per year. In addition, only 3 of those were continental mammals, and we have pictures of them shown here. The rabbit actually may not even be extinct, according to recent data. So checking past predictions can lead to confidence or increase your skepticism in future predictions. So when you're looking for where to go to the future, be sure to look to the past.
In a world full of uncertainty, skepticism, and predictions, it's not often that we have the opportunity to test or validate our predictions in present time. Here at CSU, I learned that that necessarily isn't always the case. In my research, we had the availability to utilize the MaxEnt model here to predict habitat suitability for a rare and endangered winter stonefly. As you can see from the modeling here, I was able to validate my prediction, and therefore we were able to detect a new presence point for this rare and endangered species. And what better way to alleviate the skepticism and uncertainty than to get out in the field and sample to validate your prediction?
That's what it's all about. Keep your skepticism, but make predictions, and make the kind of predictions that can be tested and validated. Thanks for joining us on Ecological Skepticism and Predictions. Class, you did a great job.